Irving and Curry. One-on-one. Irving puts it up. It's good. Kyrie Irving from downtown. And the Cavaliers by 3.
Irving raises up. Contested three is up and good for Kyrie Irving. Wow. 92-89.
In Game 7 of the 2016 NBA Finals between the Golden State Warriors and the Cleveland Cavaliers, the score was tied in 89-89 with less than a minute left. That's when Kyrie Irving hit one of the most clutch shots over Stephen Curry in basketball history. I'm going to be finding the equation of the arc of the basketball during that jump shot. I'm going to assume that the spot where Kyrie stood as he shot from is the origin, 0-0. All my measurements will be in feet, so 1 unit is 1 foot on the graph. The basketball travels in a trajectory similar to a parabola. Thus, I will be looking for a parabolic equation to match the shot. Let's start with where the basketball left Kyrie's hand. That will be the y-intercept, because where Kyrie stands counts as the y-axis of the graph. According to Wikipedia, Kyrie Irving is 6'3". In the shot, his feet get about 6 inches off the floor, and his hands are about 9 inches above his head. These are all estimations, but they're pretty close. If we add all that together, we get that when Kyrie shoots the ball is about 7.5 feet off the ground. Thus, the y-intercept should be 7.5. The next point we will find is the point when the ball enters the hoop. According to Wikipedia, a hoop is 10 feet off the floor. Also, the 3-point line is 23.75 feet away from the hoop. Now we have our second point, and we make this point in the second quadrant because Kyrie Irving, his body is the y-axis and the basket is left of him. Thus, we have our second point, negative 23.75, 10. Now let's find the vertex. It is almost impossible to find the exact point, so we will estimate. After watching the video multiple times, I paused the video exactly where I thought the ball was at its highest point. You can see it on the slide here. I circled it in yellow. I would estimate that the ball is close to halfway between Kyrie and the basket, but a little past. Also, it is 2 times the height of the basket above the ground. So here we come away with our third point, negative 12.5, which is a little more than halfway to the basket and 20. The first method we can use is using a graphing calculator to find the line of regression. I'm pretty sure all of you know how to do this, so I'll leave the details out. This is quite simple, so there's no need for explanation. Just plug the values into a graphing calculator, and in this case I use Desmos, which is a great online website for graphing equations and stuff. I got the equation to be about y equals negative 0.08 x squared minus 2x plus 7.5. The second method we can use is to solve the equation algebraically. Since we already have estimated the vertex at negative 12.520, we can use vertex form for a parabola to get the equation. We have y equals a times x plus 12.5 squared plus 20. We can get this because negative 12.5 and 20 is the vertex. If we plug in the other values, 0, 7.5, and negative 23.75, 10, for x and y, we can then find the value of a. The third method we can use is estimation. We can estimate this problem using a pattern that everyone knows. A parabola progresses in a certain pattern upwards. When we move from the coordinate of the vertex 1 unit right or left, the y-coordinate increases/decreases by a value of a, up or down. If we move 2 units right or left, the y increases or decreases by a value of 4a, up or down. If we move 3 units right or left, the y increases/decreases by a value of 9a, up or down. The pattern is that moving x units right or left from the vertex causes a change in the y-coordinates by positive or minus x squared a, where a is fixed for all values x that fit in the same one equation. This variable a is very special because it also happens to be a in y equals a times x minus h squared plus k. In our basketball situation, a point is 12.5 units right and 12.5 units down from the vertex. And another point is 11.25 units left and 10 units down from the vertex. We can use negative 12.5 equals 12.5 squared a and negative 10 equals 11.25 squared a to get that a is around negative 0.08. Once again, we can use vertex form of parabola equation to get the equation y equals negative 0.08 times x plus 12 squared plus 12.5 squared plus 20.